So in the last class, we discussed about the what are the course content, lab experiments, and we have about there are 11 or 14 or 13 what you call this uh, experiments are there. First one is the measurement of distance using the tape along with the horizontal planes and slope also with a direct ranging. Okay, and setting out the perpendiculars, use of crossstaff and optical squares. So second is the measurement of bearings. Okay, uh, yeah. Second one is the measurement of bearings and directions using the prismatic compass, and also the geometrical figures using the prismatic compass. So in the first and second experiment, you are using the basic things that's called the tape, and also the the crossstaff and optical squares. Okay, that is with the horizontal planes and also for the slope. Wherever there is undulating topography, where there is hill and valleys, using the tape or using the chain. Generally, we used to do the survey with the tape surveys. Okay, and third one is the determination of distance between two inaccessible points using the compass. So inaccessible means if you are not directly visible, the point, next point, you need to establish the intermediate point, then you move to the target. Okay, the fourth one is the determination of RL, reduced level of points using the dumpy level or auto level. Okay, and the fifth one is determination of reduced levels of points using the dumpy level and auto level. That is with the differential leveling and inverted levelings. Okay, and the sixth one is again it's elevation between 2 points. That's with a reciprocal leveling. Okay, and the collimation errors. And seventh one is the block leveling. Okay, cross section profiling, block leveling. Okay, plotting profile and cross section, everything. Okay, using black contours and graph papers and scales. Okay, and measurement of horizontal angles by repetition and reiteration methods, and also measurement of the vertical angles using the theodolite. So here the ninth one is horizontal angle, horizontal distance measurement, vertical height, accessible object using the theodolite by single plane or double plane methods. So overall, we are using the tachymeter and theodolite, dumpy level, auto level instruments for all our this one. And total session survey, we use it generally for for the survey camp. Okay, right. And the next one is just to solve the 3 points problems in a plane tables using Bessel graphical methods. Okay. The last one is the demonstration point. That's hand level and planiometer. Okay, and so what you call this. Last time you did for the the total session training for that. Okay, that's how the things the total of the syllabus content, and the first and second experiment. It's a complete base and basics, and we need to use the tape and also the crossstaff and optical square to measure the horizontal, measure the distance for horizontal planes and slopes. Okay, that is the things. Let's start with what is the So the experiment number 1, that's called a measurement of distance using the tape along with the horizontal planes and slopes using the direct lines. So horizontal distance measurement. What do you mean by the horizontal distance? In a plane surveying, the distance between the 2 points, point A and point B, 2 points. So what is the distance that? How you are going to measure it? There are many methods we discussed in the earlier also. Either you can directly use manual, that's tape survey, or chain survey. Okay. All right. Let me ask Akshay. The voice is audible. Is it clear?
Yes, sir.
So this
Yes, sir.
and what you call slides are visible. Slides.
No, sir.
No, sir.
No, now it's visible, right?
Yes, sir.
Yeah, that's visible. Okay. So what is the distance measurement? There are different types. Okay. One is now either you can use the basic level, that's called your tape. By using the tape, you can measure the horizontal distance. By using the chain, you can use the chain for horizontal distance measurement. And also the another one, those who don't have a tape, those who don't have what you call this, say chain, they can keep the foot. The how many steps the walk. So that will be, if you say for example 20 feet from point A to point B, it's a 20 steps. If you put it, it's approximately 20 meters. Almost maybe 1 or 2 feet is maybe wherever will be there, depends on the person to persons how is keep the the steps. Okay, that is another crude method nobody is using. As a surveyor, nobody is using that method, but generally if you want the rough estimation, you can use that. Otherwise you can use the tape or chain. Okay, that is a one method of measuring the horizontal distance. And another one is called, you can use the what you call the total session survey or theodolite. Again, if you are using the dumpy level or auto level, whatever the things, again you have to measure with the what you call this tape. Okay, so except theodolite and total sessions, you have to use the if you use auto level or dumpy level, it's the same base, and you need to measure the tape, measure the distance by the tape or maybe the um, total the chain. Okay, that is one. Only theodolite and your what you call total stations can give the direct readings between the 2 points. What is the distance? So that is a one. And if the points are at a different elevations, so here is the other things. So horizontal distance. Okay, so if the points are at a different elevations, then distance is the horizontal length between the plumb lines at the points. See, because when the when you are measuring the distance between the 2 points, if it is a horizontal line, I mean the land is very plain. There is no undulating topography, there is no that's called valleys and hills. You can easily measure it. That is an direct you will get it readings. If there is any two elevations, I mean 2 points different elevation, one is at the ground, another one is on the top of the hill or middle of the hill, or it may be somewhere in the elevated areas, that time it's difficult, because accurate the horizontal distance you will not get it. So you will get the slope results. Then again you have to convert those slope, the thing, the slope distance to the horizontal distance. That is a one. Okay, if you use total sessions for that particular this one, it will automatically take it as a horizontal distance. If you use the tape and all, mainly you are going to what you call this manual methods. So when using the EDM, electronic distance measurement, corrections to horizontal distance still need to be made when you are going to do the what you call drawings, right? And the first experiment, what is the require, the aim of the experiment is that, before going to start that, I wanted to ask, so all of you have the records, any records, keeping the records for this? Hello, Disha, Bhartesh, Anusha, Abdul Wahid.
Yes, sir.
Are you maintaining the book or any reference book for your this lab,
Not yet,
surveying
sir.
lab? Not yet. You have to start actually. You have
Okay,
to
sir.
start, and you can start from the introduction part, and then experiment 1 and 2. Then you have the syllabus that, so you can start writing those things. Okay, don't wait for the until the end of the day. So it will be huge for you guys. Okay. All right, and we'll tell you from the next week onwards. So whatever we are, completing the, experiments, you can start, at least the procedures, what is the operators, what is the aim of the experiments, what are the, equipments you required for this particular, what is the procedure, how to conduct the experiments, all these things you can, keep it ready, right? So when the college, reopens for you all, and for, physically, if you are here, then you're going to start the experiments actually in the ground, then we can put all the readings. But till the time, so you have to, keep the, the other stuffs like a procedure, operators, and the equipments, and the aim of the experiment, everything, each step, you can finish it now itself only. Okay, that would be a better. Otherwise, it's a difficult for you. Okay, all the, the lab experiment, you have to do it at the end of the, 11th hour. It's so difficult for you guys. All right. So this is things I wanted to convey you. And the other one is, you are in a 5th semester, and have you started have you finished what you call this, I would say it's EVS, this one, the MOOC, Gurdeep, Desha, Rishikesh Babu, Mahesh?
Sir, I finished, sir.
Huh? EVS,
Yeah, sir.
EVS MOOC.
Introduction to
Did you
Environmental Law.
finish?
Yeah, sir.
Okay. Got the certificate.
Yeah, sir. I sent in mail also.
Oh. I will put one, what you call this, Google Classroom. Okay. I will send the, assignments for MOOC EVS. So you can upload there only. Yeah, that is easy for me to, download the things.
Okay, sir.
With your USN, start with the USN and your name. As you did for the, geology lab and all, right? You did the, answer sheets, right? So your USN number and your name, that is your file name. That would be a better. Otherwise, it is
Okay, sir.
difficult to download it and sort out the things. You got it? So I will create the Google Classroom for this, for EVS, the MOOC and all. So you can upload there only. Don't send it to the what you call in the email ID. Okay, that's difficult to track it. And put this message to the 5th semester students group. Okay, for all of you. Okay, right. So who is going to put that? Is there any? Who is the class teacher here? Now here in this batch, anybody can. Namita Oman. Okay. Akshay, MN. Akshay.
Sir.
You put in the group so that they can send it in my Google Classroom for UVS. Okay.
Sir, Gurudeep is admin, sir.
Gurudeep, huh?
Yes, sir.
Okay, Gurudeep.
Yes, sir.
You can start, put the message to the students so that they can upload there only. Okay, once I send the link to you all.
Okay, sir.
That would be the easy. I will send the, uploading this one assignment in that. You can reply that. You can, while replying, you can upload the things. That would be the better. Yeah, and yes, that's the things I wanted to convey. And yeah, so here is the, okay. For first experiments, it's a very simple one, and you don't need any much of what you call your latest technology instruments and all to measure the distance between the 2 points. Okay, the aim of the experiment is that to measure the distance between 2 points using the direct ranging. That is the one. Another one is using the crossstaff, and the arrows. That is there. Okay. What you required here? So here there are 2 experiments within that in a small experiment. First one, A and B, measurement of distance using the tape along with the horizontal planes, slope, and direct ranging. And in that second one is the setting out the perpendiculars, the 90-degree angles, okay, for a particular area. So use of the crossstaff and optical squares. Okay, these 2. All right. For here, the first one is what we are discussing. That's the first part. That is, to measure the distance between 2 points. using the direct ranging. Okay, instruments, you need the ranging rods, tape and arrows. This is more than enough. Okay, right, need the ranging rods, tapes and measurement. Right. All right, so what is the the things you need to follow it here? For measurement of length of the survey line, it is essential to stress the chain or tape. Either you can use it a chain or you can tape. Okay, so better to easy to carry in the field, tape is the best one. Okay, and it is well marked with all the the meters or even a feet and everything there. No need to do the conversion. If you use the chain, again you have to convert how many, one chain length is 3 meters and 20 meter of chain of length is it's 100 feet. Again you have to convert. So those calculation will not be there when you are using the tape tape. Okay, for measurement of length of the survey line, it is essential for stretch of the chain or tape along with the along the line joining at the end with the two stations. If the distance between the two stations is less than the chain, okay, the chain can be stressed directly without any establishing the intermediate point. As I told in the last class also, I showed that. So if your chain is less, if your chain length or tape length is lesser than 2 points, again you have to establish the another intermediate points. So if the distance between the two stations, the chain length is more than that or tape length is more than that distance, no need to establish the third point. I mean establishing the intermediate point. That is a very simple funda here. And however, if the distance is greater than the chain, it is necessary to establish the intermediate points, which are lying in the two end stations before starting the measurement, right? And this type of process of establishing the intermediate points on the straight line is known as a ranging. Ranging in the sense, it should be in the proper alignment, right? Proper alignment, ranging out in the survey. That's called your proper alignment. Direct ranging is done when two end stations are intervisibles. So whenever you are doing the survey, the line, survey line from one station to other station, it may be 1 kilometer or it may be 100 meters. The both should be intervisibles. If it is not intervisibles, there is a big, there is again you have to take a diversion or maybe you have to establish the intermediate points and all, right? So direct ranging can be done by eye or through the instruments called line rangers. That's called your line arrangement, line alignment. I would say it's a line alignment. Okay, direct ranging can be done by eye or with an instruments called a line range. Okay, this is the things, right? And the next one is let A and B to be the two end stations on the survey lines. AB is erecting a ranging rods or poles on both sides at point A and point B. Okay, and behind the stations, the pegs, the has to be marked on the ground. Okay, for erecting the ranging rods, and it has to be hold firmly with the right end and such as its lower end, it should not be the 300 mm, should be at the 300 mm ground. Okay, and after erecting the ranging rods at A and B, the survey stands behind the third ranging rods at a distance of about the half a meter to align it properly. The assistant asked to hold the another ranging rod C, that's for your proper alignment. Okay, approximately on the line E and B. That's for your alignment at a distance not a greater than one chain length. One chain length in the sense that's a 3 meters, 3 feet. Okay, from A station. That means you need minimum 2 points to align the line, and if there is a 3 points are there, that gives you the more accuracy there. Okay, that would be the better one. Okay, then the surveyor directly he can assist to the move to the ranging rods by traversing to the line AB till the third rod at the point ABC. That's the third point, or exactly in the same straight line. Okay, and this is how the surveyor then signals or fixed to the rod at point C. Likewise, the rest of the points you can establish on the line AB at a distance measuring with the particular areas. So here is the things. And here you can see this because of undulating topography. Here you can see this. You need point A to B. You need to measure it. What is the distance here? You cannot measure it directly because it is not a horizontal. Because it is not the plain land here. It is an undulating topography. Here you can see this. So while there is a undulating topography, there is a chances of error will be the more if you are not carrying out the survey properly. So point number A. Let's start with the point number A and C point is the intermediate point you establish, and then from here you can easily see this. So this is how you can do the the A to B the distance measurement by using the chain, or it may be the tape surveys. Okay, so this is a one method. Other method that you can use it with a what you call this in a plain land, directly you can do it. No need for intermediate stations here, right? And finally, what you are going to do with this, so the results measured between the 2 points A and B, how much it is there, that you need to measure it, keep it here. And next experiment within this, in the first experiment, sub-experiment is setting out the perpendiculars on a given line using the crossstaff. Why we are using this perpendiculars? So why we are using the the crossstaffs? The crossstaffs are most important while doing the survey, especially for griddings, not for a line alignment. Okay, line alignment you can do it with your own this ones, or you can using the bearings. But for this griddings, where you are doing the levelings, block levelings, that time it's a very important. You have to use the crossstaffs. Otherwise, you are all the survey lines. It will go out of your survey areas, out of your specific areas. Okay, if there is 50 meter by 50 meter areas, it will not be there in the proper shape. One corner it will be a 45 meter, another corner will be a 48, another will be the 50, another next fourth one is 51. This is how it was when it was not in a perpendicular to each other. So when you are not setting the lines in the perpendicular, it's a 90 degree. At that time you have to use the crossstaff to set out the perpendicular at various points on a given line using the crossstaffs. That is your aim of the experiment, and you have to use the crossstaffs and ranging rod. Okay, yeah, this is set out the right. So this is a procedure which you need to follow it here, and let A and B the two end stations at survey line AB. Okay, and select a point C on chain line from where the perpendicular is to be set out. Okay, and the crossstaff is held where at a point C with a pair of opposite slits directed to the ranging rods at A and B. Okay, looking through the either pair of slits, the direct surveyor directly fix this ranging rods at D. Okay, and thus the perpendicular to the CD is set out. I mean the C and D points can be set out on ABC. Okay, right. Here is the icon. You can see this. It's a very simple one actually. It's not a very complicated. There is the perpendicular. So this is how this is your line AB. Okay, these are the 2 points A and B are there. So here you have to establish the C point now here. Okay, from here you can establish the grid. So say for example, this is your ground. This is your survey area. So you need to survey it A, B, C, D like this. Okay, and you need to make the entire area into block leveling or a grid. what do you need? You need to direct the 90-degree angle towards here, towards here. But this time you need to hold the crossstaff here and align this intermediate points. Okay, align these intermediate points and the end points properly, so that you will get this here and again here. For each grid you have to do the intermediate point, and so that you can 90-degree angle, fix it perpendicular to that, so that you can easily get it in a proper surveyed cap. Okay, so perpendicular, these things has to be set out using the crossstaff only. Crossstaff for getting the 90-degree angle, because we are not using any the what you call total station or dumpy level or auto level here. We are using the only crossstaffs, ranging rods and tapes. That's why it's a manual one. Okay, right. And yeah, here we generally use this the arrows to fix the corner points. Say for example, I would say this is your area of interest for survey, and first we will start with this point. Okay, and we'll fix the arrows here, then measure the with say for example 100 meter by 100 meter of grid, this your study areas for surveying. First we fix these points, then fix the arrow here, one arrow here. Okay, fix the arrow at this particular place. Okay, then you take a alignment here, 90-degree angle. That's what the 90-degree. Here we are not using the compass. Keep it in mind, we are not going to use the compass here. We are going to use the crossstaff. Crossstaff only we are using. That gives the only 90-degree angle, not a 45-degree angle. We need the 90-degree angle, especially for griddings, especially using when you are using the crossstaff. That is only for the 90-degree angle. Okay, so here keep the arrows here. One fix the arrow, and from here 90-degree. Okay, the crossstaff, and in between you can establish the intermediate points, and third point also you can fix it. And the alignment you can do with the crossstaffs. That should be the 90-degree. Same thing you can continue for the rest of your all the corners, right? And this arrows generally we fix it for the corner points of your surveying areas, not for intermediate one. Intermediate one, once you aligned it properly, intermediate points not necessary to fix with the arrows. Arrows only for the corner points. Okay, and in between points you can fix, you can mark with any paint, or you can fix, just keep temporary one for the stone, or it may be a small wooden sticks, you can put it there. Otherwise it's not necessary, right? Yeah, this is the one, the the arrows which you use it for, fix at the corner, so that it's it will not be disturbed properly. Now I would say it is you can fix it at in the proper ground, so that it will not disturb by anyone there. Okay, and the next point is the crossstaffs. So crossstaff will be like this, and there are different types of crossstaffs are there. Okay, and this is a staff, crossstaff, and this is a pole. Okay, and that's made from the survey drawing instruments. Some are using the metal one, some are using the wood one. This is a wooden stick, and this also wooden sticks. Some are using the metal one, this, and this one will be the top. This one, the angles will be the wood one. Okay, yeah, this is how the things we can. Yeah, here you can see this. This will only we use only for the the 90-degree angle, not other for other angles. Okay, yeah. So this is prismatic compass with a sense, and but here we need this use alignment. This is one alignment, that's a 90-degree. Another one, that's a 90-degree angle, right? And here you can see this, the popular one called this stick is the metal one, and this one is the wood one. Generally everybody is using this one. Okay, crossstaffs. I'm going to show the crossstaff for the top bottom. Okay, right. Yeah, these are all the the different what you call this at the simplest instrument for setting up the right angles. There are also open crossstaffs. This is open one, and French one. This some people are using the different one, adjustable crossstaffs. And what I showed, most of the most of the people, they use this only the wood one, okay, and easy to carry it, and a lightweight. That's basic things. Okay, right. So let's go back to the field of these, where we are using this the staffs actually. Okay, but for the what you call our first experiments, we are not at all going with any staff readings or with any total session, or it may be any the dumpy level, auto level instruments. We are using only the arrows, crosscuts, and the ranging rods. Only alignment and a distance. Alignment you will get it from the crossstaff, and distance we can measure with the tape. That's all. Ranging rod is also for the corner points of your surveying areas. Okay, that is a one. So let me show you the the where the crossstaffs are using and how we are using here. Right. Let me show you some of the pictures. Here, yeah, we are not using here. No. Yeah. Here they are using, but not for the other, the block leveling. They are using the tape for measurement of horizontal distance. Okay. Yeah. Let's show you this complete so that you will get an idea. No, they're not at all using this. They are surveying for the complete, water body areas. So this is one. Yes. No. We are not using this crossstaff here. Let me show you some of the pictures so that you can easily understand what's going on here. Yeah. Oh yeah. I think we have this here. Yeah. No. We're not taking up this. Yes, they are focusing from this levels. Yeah, here for leveling, are using arrows, yeah, ranging rods. Yes. Here we are using this. Look at this. She is fixing the arrow here, and they have fixed the one those the corner point here, and there is called another person standing here who is waiting for the arrows. Okay, and here one more team is fixing the next point, intermediate points here, right? And this is yeah, and this is generally it's for the block leveling. Okay, this is generally we use it for the block leveling, and this block leveling generally we use to create the using the orals, and it is generate for called the contourings for this for block levelings. Okay, right. Yeah, this is how we need to fix the four corners. One is here, another one is here, and another ranging rods are falling down here. This one, and it will come up to the. Can you see the one more here? It's too far, I think. You cannot see this properly. Okay. Oh, here it's there, and this is the your grid, and in between you are going to make the 5 meter by 5 meter or 10 meter by 10 meter grids. So to establish the grids, and you need the exactly the 90-degree angles. Okay, from here you need the one line that should be the 5 meter by 5 meter or 10 meter by 10 meter as per your requirement. You can establish here. So, and when you are establishing this line, intermediate lines, that should be the 90-degree angle. How you are going to use it? You are not going to use the what you call the compass, because that also will give you the alignment. But when you use the crossstaffs, that will give you the perfect the alignment as well as the angles for it. Okay, should be the proper way, right? And yeah, one is here, one is here, right? This is generally we use it for the black leveling. Okay, black leveling for the uh, especially in the next to the overflowing area of the water tanks, right? And should show the what do you call this? Yeah, show you the crash tabs properly this way. Yeah. Here nobody is using the crash tabs because they're not performing that. Nobody is using the crash tab here. No. She's using this. Yeah, no, nobody is using that crash tabs. Okay. So this is the all about the how to set up the the how to measure the horizontal distance using the tapes and crash tabs for the to set up the the perpendiculars for the grid making the grid. That's called your block levelings. Wherever you are generally taking the block levelings, there we have to use the gridding. That may be a 5 meter or it may be a 10 meter grids. Okay, to set up the the called overhead tank and other work to make it leveling properly. How it is done? That's for your cuttings and fillings. Okay, those things we have to use it for that purpose. You have to use the proper gridding and for tape, and also as well as the chain. If you have the chain, you can use it, but carrying is a problem because it's heavy, and better use it tape even in lab experiments as well as for uh, field camps, survey camps. You can use it. And third thing is you have to use the arrows to fix the corner first initially before fixing erecting it ranging rods. So the ranging rods, you can, once you've established in the corner points, fix the corner points, you can remove the arrows. Okay. So arrows generally we use it for initial stage. Okay. Then we'll fix the the ranging rods at the particular place, so that we'll we can remove the what you call this the arrows. Okay. Right. And yeah. This is how you need to perform in the field. It's a little bit looks like a tough, but of course you will enjoy the trip and you learn many things. That is especially with the the measuring of the the total area of this tank, water bodies, and how much dam sorry the check dams, the what you call this height of this small dam. You can erect it. If you height it, how much water is going to accumulate in the particular areas. That is also this also you can calculate. Okay, and when you start with the collecting the readings from this particular areas, and you are going to plot it in the camp areas, but at that time you have to take care of the all the RLs. You should not cross each others, so that the final answer, final the your area calculation will be a it will not be any wrong. If it is any crossing, there will be issues. Okay, those things you need to take care at field itself, not in the campsites. So field itself, you can correct it. Once you come back to the college, the camp, that's very difficult to do that. Okay, that is about the things. Okay, right. Yeah. Camp 2 is Yeah, it's not here, right? Yeah. So this is all about procedure, how to conduct the experiment, how to perform the in the field of taking the readings from the tape, from the the what you call this crash tabs, and how to establish the grids using the crash tabs, particularly in the 90-degree angles. Okay, and rest of the actual the what you call the experiments we can conduct, you can perform when the college is reopens. Okay, and this experiment we can do it very easily, and it takes hardly 1 hour time. Okay, we'll give you the area in the college campus itself only, so that you can easily perform this experiment. Okay, right, and this is all about the today's the class, and you can take a note of this, all this the points, and it's concerned to the 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 experiment number 1. Okay, and keep your the notebook for this particularly. Okay, surveying practice, so that when you get the records you can transfer it easily. Okay, this is how we are going to conduct this the classes. Actually survey practice class should be in the not online, it's offline. It's very difficult at this time, pandemic time. Okay, all we need to do things is that, and you need to understand and how to conduct, what is the the concept and the fundamentals of surveying. Okay, this is a very simple, and easily you can do the surveying. That's not a big issues for this. Okay, right. All right, Alec, you have any issues, any the what you call the questions regarding this session?
No,
Actually,
sir.
no, it's clear. You can conduct it. If I give the arranging rods and
Uh,
what you call arrows, and of course you cannot do it alone. I know this. It's a teamwork. It's a teamwork. Minimum 4 people is required. Okay, it's not a
yeah,
one man can handle this. It's not possible. It's a survey work. It's a teamwork. Okay, right,
mm-hmm.
right.
Yeah.
But you can do it. You can perform it. Okay. What about Bhartesh? Bhartesh, are you there?
Yes, sir.
Disha? Yes. Can you perform this experiment?
Yes, sir.
Okay. How about Gurdeep? Disha?
Yes, sir.
Yes, sir.
Is it clear? Okay. Rishikesh, Mahesh?
Yes, sir.
Is it clear?
Yes, sir.
Right.
Yes, sir.
Right. Right. Uh, yeah. And what I was going to see this. Right. Nitish Kumar. What about Nitish Kumar?
Yes, sir.
Hmm?
Hello.
Pranav Jaikant.
Yes, sir.
Right. Right. What I want to show is to ask you some questions on this. To show no. Okay. For what purpose they are doing this? Block leveling. Anybody can answer this? For what purpose of doing the block levelings? We are making the block levelings for maybe it is 50-meter based on the availability of the place. Okay, it is not hardened rule. You can do it 500-meter by 500-meter. That much of space is not available in the particular areas. So for that purpose, generally for exercise point of view, guys, and we used to keep the very short distance, like 50-meter by 50-meter. That too is very difficult some extents. So 50-meter by 50-meter, we are going to conduct it. For what purpose we are going to do the block leveling? So the grid, how many, what is the grid, intervals based on your requirement. It may be a 10 meter or it may be a 20 meters. So that it should not escape any the undulating topography here, because when the land is not the proper leveling, so that we can't expect the levelings, block levelings. I mean, okay, this block is higher elevation, this block is lower elevations. When you make the grading now, it is it gives you okay, this block is gives the higher elevation, this is lower elevations, and this is a little bit upper elevations, to identify which area is lower land, lowland, and which area is the highland. It may not be the hill and it may not be the valley, but whatever we are surveying the areas, within that areas, what is the leveling here? Okay, and this block, this area is, we are going to divide it into the different blocks. That's the area dividing. And I told you that you can do it the triangular, but here it's triangular is not going to work. You are going to do the 10 meter by 10 meter gridding. First you take it 50 meter by 50 meter, the corner, the border, outline of this area. That is your area, and within that 50 means what you call this 10 10. 5. The lines will, you need to establish here, and another 5 lines. So you will get the 10 by 10. How many you will get it there? 100 grids. Within 100 grids, how many, the grids are comes under, say for example, this is, 540 elevation, and this may be the 532 or 33, depends. Okay, each grid, what is the elevation? Then we will establish, generate the contours. Okay, by taking the RLs. RL where you are taking here, this is for block leveling, I'm telling. For today's experiments, we are not going to do the block leveling. We are going to just establishing the the measurement of between the horizontal measurement of a distance between the 2 points. That's what today's the experiments. But behind that, what we are doing the block levelings. So the RL, we are starting with the, this is how we are going to carry the RL here. It's not here. Here we have. Generally, from the known RLs, what we are discussing in the last time. So where is the bridge here? Yeah. See here, generally the RLs, known RLs, can carry out from the here. Okay. This is a 881 point. Some are saying that 883. Some are saying that 881. That depends on the person to persons. The oral, I mean the carrying out the things. Okay, these are the known orals where we are going to keep, and they are going to establish with respect to this. So they are going to establish the rest of the orals and the points and those things. Okay, they are going to carry out the survey, rest of the surveys. Okay, and this is the same locations. This is the the bund what we have seen here. Yeah, this bund is this the water body is in the bund areas. The same thing are here. This is the one actually. These guys are standing below this. That's what this that is the place where we are here. Okay, and here they are going to focus for the block levelings. This block leveling areas. Okay, they are surveying for that. Right. So this is the things can do it easily. This today's experiment is very simple. It's not much complicated, and you can do it, perform it very easy way. Okay, that's what all about the today's experiment, right? Yeah.